But our speaker now is Dr. Nick Caputi. I hope I pronounced that correctly. Nick is the supervising scientist of the invertebrate fisheries of the Department of Fisheries, which involves research on rock lobster, pearl, oyster, prawns, scallop, crab and abalone. His research focus is fisheries stock assessment, catch predictions and climate change, having published over 80 peer-reviewed papers and book chapters. He has participated in reviews of fisheries research and climate change projects in the USA. Welcome, Nick.
Thank you very much. I'll be talking about a 4-year project that we've recently completed looking at climate change effect on fisheries, and it was a joint project with CSIRO, and I'd like to acknowledge Ming Feng, who's a CSIRO oceanographer who's been a major contributor to this project. I'll be looking at the WA marine environment, looking at the long-term changes which have occurred, some of which have already been presented already. Also focusing a little bit on a marine heatwave event that occurred in 2010-11 and the impact that had on fisheries. And then looking at some case studies, rock lobster, looking at a rock lobster case studies and looking at the effect of that heatwave on some fisheries. And finally finish off with some take-home messages from a research management perspective, how can we adapt to the changes that we are seeing. Start off by saying that the Lewin Current is a major focus in terms of its effect on fisheries in West Australia and the marine environment. It's one of the longest boundary currents in the world, over 5,500 kilometres, and whilst we see the current here coming down the west coast, which is the red warm waters coming down and the eddies that it forms, it also flows along the south coast, plus Albany and Esperance, and when it's particularly strong, it reaches the west coast of Tasmania as well. As I said, it's a warm, low-nutrient waters, and the climate models indicate that it's got a weakening trend. They predict in the next 40, 50 years, we'll see a 15 to 20% average decline in the strength of that current. However, before we get to there's other factors that affect that. And as someone said this morning, there's not a linear trend in those things occur. There is annual variations, and typically the Lewin Current is weaker during an El Nino, which we're going through now, and stronger during a La Nina event. But also there's decadal variations. We saw from the 70s to the early 90s a decline in the strength of the current, but from the early 90s to the late 2000s, we've seen an increasing strength in the current. So if there is a long-term decline in that Lewin Current, there's going to be decadal shifts and obviously strong year-to-year variation. Looking at water temperature increases in West Australia, and this is a paper published by Alan Pearce and Ming Feng in the mid-2000s, looking at water temperature increase over a 50-year period. And one of the hotspots of water temperature increase is on the lower west coast of Western Australia. And this was a particularly interest to us from a fisheries perspective because the Western rock lobster fishery operates in this area and its larval movement occurs virtually in this area. So and certainly it was of concern to see how this would have impacted on the Western rock lobster fishery, but it also impacts on a lot of other fisheries. Looking at this in a bit more detail, we see that if we look at that water temperature increase over this sort of 40-year period, we see it's not a smooth decline in all months of the year. If you look at the autumn-winter period, there is a strong decline, a strong increase in water temperature in the lower west coast in the autumn-winter period, but much less so in the summer and the spring period. Also, the other thing to notice is that it's strong on the lower west coast, but if you look at the northwest, the rate of increase is much less, and also on the south coast, which is probably of interest to this audience, it's much less as well throughout the months. So that it's not an increase that's the same spatially, it's not an increase that's the same temporarily. And then looking at what might happen over the next 40, 50 years, and this is just looking at temperature increases, and we saw the RCPs, the different scenarios come in, But the thing which struck me is that irrespective of which of these scenarios in terms of climate change effects you look at for the next 100 years, if you look at the next 30, 40 years to 2050, irrespective of the scenarios, we are expecting globally a 1 degree increase. So if you go back to the graph that I showed you previously, that over the last 40, 50 years we've had a 1 degree increase in water temperature, over the next 30, 40 years we can expect another 1 degree increase in water temperature, irrespective of the scenarios that we look at. How do we deal with this? And one of the ways that we to look at it, and we can't study every species in terms of its climate change effects. So the first thing that we did is undertake a risk assessment in terms of which species may be more vulnerable than other species. Some work on this had already started in Southeast Australia, in Tasmania and Victoria, New South Wales, where they developed a sensitivity criteria for different species, and they developed looked at 12 attributes to measure the sensitivity of species. Then we looked at the exposure, the likelihood of that environmental effect changing, and then combining for each of the species the sensitivity and its likely exposure, we developed a risk ranking for these 35 species across West Australia. And this is all, most of what I've talked today is produced in a fisheries research report, which is on our website, also a Fisheries Research and Development Corporation website as well. So these are the highest ranked species in terms of their high sensitive to climate change, and there's a high exposure to those environmental variables. And you can see there's a lot of our key species there in terms of western rock lobster, rose abalone, which occurs on the south coast, pink snapper, another important fishery in the Gascoyne lower west coast, tiger prawns, herring, and scallops. So each year, a lot of the key species that affect the lower west coast and the south coast are in this high risk category. Okay, now just looking at the western rock lobster as a case study, whilst it occurs, it is one of the fisheries where we've got the longest time series of information, probably in any fishery in Australia, going back sort of 40, 50 years, and it is one of the fisheries from a research perspective has been studied intensively, so we can measure the impacts of environmental changes on its abundance and distribution, and that's why this was a major focus in as a case study for climate change effects on fisheries. Just a little bit about the life cycle. It undergoes a larval life cycle of 9 to 11 months, and it goes out in the open ocean, 1,000 kilometres offshore. After that sojourn out in the Indian Ocean, some, and a small percentage, return and settle on the inshore reef areas of the coast. And this is the last larval stage, or the purula stage, where they settle in the inshore areas, typically less than 20, 30 metres of water along the coast. We measure the abundance of these purulas using these artificial collectors that mimics the habitat that they like to settle in, typically like to settle in on limestone holes within the rocks. And we measure the abundance of these purulas that settle on these collectors each month to see how that abundance changes from year to year. And the importance of this is that if we measure the abundance of these guys, then we can predict the catch 3-4 years ahead quite reliably. And in fact, these collectors is one of the major breakthroughs in lobster research around the world, because this system, developed in West Australia in the late 60s, has been used in many lobster fisheries around the world since then. Now this shows the abundance of those purulas which settle on the collector on an annual basis, and you can see that, and it goes back to the late 60s in a lot of regions. And you can see that there's years of very good settlement, 2000, and then there's years of very poor settlement. And as I said, this provides a catch prediction 3-4 years ahead, that if the settlement is good in this year, then we know that it's going to be good catches in a few years' time. If the settlement is poor, then we know that the settlement's going to be poor in a few years' time. So it gives an ability to bring in management of the fishery before this year class becomes legal size. So if there's a poor year class coming through, we can be a bit more protective of that stock, reduce fishing pressure, and not allow and have a lower quota in that sense. The other factor in terms of this variation, it's been well explained. After 35 years, we had a good understanding of the impact of this variation. The good settlement was associated with a strong low current, warm temperatures, and winter storms. Strong winter storms produced these good settlement, and the reverse conditions produced a poorer settlement. However, in 2008, we had the lowest settlement on record for the 40 years, and this low settlement was not explained by these environmental conditions. So effectively, after 40 years of knowing the factors that affect the lobster fishery dynamics, we're back to square one in terms of our understanding of what was happening. This sort of illustrates the importance of the perilous settlement and its impact on catch in the Lancelin area. So if the settlement is quite good in 1 year, we get 2,500 to 3,000 tonne catch. 3-4 years later, if the settlement is quite poor, the catch is 1,000 to 1,500 tonnes. So certainly in this area, the level of settlement is key to what the catch is going to be a few years later. So that illustrates the importance of when you get a record low settlement and you don't understand the reason for it, the first question is it due to the breeding stock being overfished, or is it due to some other environmental condition has perturbed the system that we weren't aware of? One of the things that we did was, in terms of trying to study this, was look at the how the larvae moved offshore. So we developed with CSIRO an oceanographic model, a three-dimensional oceanographic model, looking at how the larvae move offshore to see has there been any change in the currents, which means that the larvae are being swept away and not returning back to the coast. Let's see if this works. Here we go. So this represents larvae being released during the spawning period, and the easterly winds, and that spawning period is typically in the summer, when there's easterly winds moving the larvae offshore. And you can see the larvae move well offshore of the continental shelf. The continental shelf is here, and the lobster fishery occurs all within the continental shelf. But you can see the larvae move well offshore, and as it approaches winter, they start to come back. The winds become westerly winds. If there's a strong storm, that's the importance of the strong storms, bringing the larvae back to the coast. And typically the settlement period is between August, September through to November, December. So we looked at this, and one of the things that highlighted that the result was this, that the level of settlement that we achieved was very sensitive to the larval release. And this modelling work, whilst we showed it for the 1999-2001 period, we did it for 17 years to look at different years and the variation in low and current strength, variation in the westerly winds. So we did model different years. And we identified that it was very sensitive to the timing of larval release. So we focused on that a little bit more. And we looked at, we've been doing breeding stock surveys since the early 90s. And when we do the breeding stock survey, we look at the mature females and the females with eggs and look at what stage are those eggs. And what we did notice in that year of very low settlement, we had the earliest start to the breeding life cycle in that sort of 20-year period, 25-year period. So that was the first hint that a change in the timing of spawning was a key factor in causing that downturn in settlement. And sure enough, since the mid-2000s, there's been a generally earlier start to spawning than in the 99 and late 2000. And when we looked at what was causing this, it was influenced by water temperature during that winter-spring period, was bringing the timing of spawning earlier, and that was probably creating a mismatch with the other part of the life cycle, remembering that the larval life cycle for this species is up to a year, 9-11 months, and even over that. So that so the timing of spawning was appears to be the conclusion. Now, the other thing that I did mention is that winter storms plays a major role in the return of the larvae. So we looked at the time series of that, and I think you've heard a number of talks on rainfall. And we focused on the rainfall effect on the lower west coast, the coastal locations from Dongra through to Mandurah, because we were trying to get an index of the storms hitting the coast. And sure enough, over the last 3-4 years, and that perilous settlement, whilst it was low in 08-09, record low, there was 7 years of below average settlement. So there's been a period of very low winter storms over this period. And again, if we look at the projections, the Indian Ocean Climate Initiative indicates that these declining winter storms is projected to continue. So we need to be able to adapt to that. Okay, moving on to the heat wave. I'm not sure whether many of you are aware of a marine heat wave that affected the West Australia coast in 2010 and 11. It was associated with a very strong La Nina event that occurred at that period, I think one of the strongest this century. And it's virtually started in November 2010, where we noticed a warm body of water off Exmouth Gulf in November. By December, it hit the coast and intensified in January and peaked in February. Late February peaked with 3 degrees above average over a large part of the coast, and that even extended all the way down to the lower west coast with a smaller, less of an influence on the south coast, which I'll show you in a minute. Then it started to dissipate in March and April. And in some locations, this represents an average over a large area, but in some locations, 4 or 5 degrees above that average occurred in that area. And it affected over 2,000 kilometre of coast. This shows the water temperature from a number of locations, from Ningaloo up north through to the Capes region and the Rottnest region in the metro area, then Albany and Esperance down below. So 10, 11. So this is the record high temperatures that we got on the west coast. It was above average in Albany and Esperance, but nowhere near the record highs. This shows the anomalies, which is the amount above average the temperature was. And you can see this is Ningaloo through to the Capes region and Albany and Esperance, again above average, but nowhere near as high as what it was in the Gascoyne region and the lower west coast. But it wasn't only just the high temperatures in 10-11 that was above average. They stayed above average for 3 consecutive summers. And in fact, the peak temperature in the south coast was in 2012. You can see Albany Esperance, the peak anomaly over that whole period occurred in 2012, the summer of 2012. And again, to put it into an international perspective, at a recent climate change effects on the marine environment in Brazil earlier this year, the West Australian marine heat wave was compared to 3 or 4 other major heat waves that have occurred all over the world in the last 15 years. And there's been 2 in the Mediterranean in 1999, 2003. There was a recent one in the North Atlantic where there was major impact on fisheries. So this one, in terms of its space and in terms of its intensity, matches major marine heat waves that have occurred globally over the last 15 years. So what was the impact on the marine community? I mean, it wasn't all bad news. Let's start with the good news. A lot of tropical species range extended south. In terms of rabbitfish, there's a new population being established in Coburn Sound, which has never been there before, and a fishery started on it. A lot of Spanish mackerel caught on the lower west coast and probably even on the south coast. That was the good news, but there was certainly a major impact on seagrass and algae habitat, and sort of 5 years later, some of those species haven't come back. So in fact, new species have replaced them. There was coral bleaching at the time in Ningaloo and even at the Abrolhos, and there were fish kills. In particular, I'll talk about one in terms of the Rowai abalone in the northern end of its range in Kalbarri was almost completely wiped out. My interest is in invertebrate fisheries, and we're seeing still impact of this heat wave on the metropolitan Rowai abalone fishery, and we've lowered the quota over the last few years to adjust for that lower abundance. The blue swimmer crab in Shark Bay was shut for 18 months because of the low abundance of crabs in Shark Bay. And the Shark Bay blue swimmer crab fishery was the biggest fishery in Australia at the time. It's since reopened, but with a quota of 400 tonnes compared to 800 tonnes it was catching before. Shark Bay and Abalone scallops were shut for over 4 years and opened this year for the first time in 4 years in one of those stocks in Denham Sound. And again, just to illustrate that it wasn't all bad news, there was an impact on king and tiger prawns in Shark Bay and Exmouth, but in Shark Bay, where it's typically 2 degrees cooler than Exmouth, it had a positive impact. In Exmouth, it had a major negative impact. Indirectly, in terms of the heat wave, affected the seagrass in Exmouth, virtually wiped it out, which had an impact. And the seagrass is a key habitat for tiger prawns in Exmouth, and that affected the tiger prawn catch. And now, this year, it started to come back quite well. Looking at I mentioned the Kalbarri abalone fishery. This was before the heat wave, and this was afterwards. As I said, virtually everything was wiped out in terms of the abundance of the roe. And what we've done, we've looked at, we didn't believe that this stock would recover by its own, so we've looked at the translocation of abalone from other areas into Kalbarri, and also we're looking at hatchery reared abalone, hatchery reared from Albany, I should say, and these have been released in that Kalbarri region now, and that seems to be quite successful. In the metropolitan area, there's also been a downturn. The fishery hasn't been shut in the metropolitan area, but you can see this is the abundance of the 1-year-old abalone, and typically they mature, they become legal sized at 4 or 5 years. And you can see the abundance of the legal sized abalone was the lowest that we've been monitored since we've been monitoring it in the late 90s. And just to illustrate that it was a environmental driven effect, there's also a location at Waterman in the Marine Reserve which has never been fished over this period except for the odd illegal activity, but it also showed record low recruitment post the heat wave. So I think that confirms in our mind that this downturn wasn't due to overfishing or anything like that, but it was due to that heat wave effect on the marine, or that marine environment effect. Looking at the scallop fishery, and as I said, there's 2 stocks of scallops in northern Shark Bay and southern Shark Bay in Denham Sound. There's another important stock in the Abalone, and these are our key stocks. There's smaller fisheries that operate not every year, but in Rottnest, and there's a small fishery in Esperance. We've been monitoring the stocks in Shark Bay from the early 80s. And we monitor 2-year classes because they typically survive 2-3 years. Naught Plus are the new recruits, which are about 6 months old when we monitor them in November, and the 1 Plus are the ones which have just been fished, and they're about 18 months when we do the survey. And you can see when the heat wave occurred in 2011, we had a record abundance of the 1 Plus, which went from the previous minimum was 50 per nautical mile. We were down to 1 or 2 per nautical mile. And this is a log scale, by the way, to illustrate the large fluctuation that we get. And similarly with the Naught Plus, the recruitment went down to very low levels. We've started to see a recovery last year, and we're virtually this week doing a survey of the scallop stocks in Shark Bay, so hopefully we'll see a continuation of the recovery. And this is one of the fisheries where cooler temperatures is beneficial to the scallop stocks. So the El Nino that we're seeing now will result in cooler temperatures, so that's good environmental conditions for this fishery. And I mentioned the decline in the crab stocks in Shark Bay. Cockburn Sound crabs has been shut for 18 months as well, and it's still not looking too good. But if we go down the south coast in terms of the blue swimmer crab stocks, and this illustrates the catch and fishing effort for the last 15 years, you can see that there was a spike in 2001-2, and that spike occurred a year after a very strong Lewin current very strong La Nina in 99, 2000. Then things went back to normal. Catches dropped from 40 tonne back to the usual 2-3 tonne and small bycatch. And since the heatwave in 2011, there's been a build-up in stock. Princess Royal Harbour in dark blue, Wilson Inlet in the turquoise colour, and the total catch has reached sort of 40, 50 tonne. Whether this will continue for another few years or whether it will come back to this level of a bycatch type species remains to be seen. But again, it's sort of illustrating that there's winners and losers in these changes in environmental conditions. And for the South Coast crabs, it's a winner. For up north, it's not so good. By the way, this 2015 is incomplete data, so don't worry about the downturn here, because I think the catch in 2015 will be quite good as well. And remembering that the peak water temperature in the South Coast did occur in 2012, so that's why this is continuing a little bit more. I mentioned different tropical species moving south, and I noticed that there was a brochure on the red map outside, so please get one if you're interested. But this is it's a community science project that's occurring Australia-wide, where if you are a keen fisherman or a keen observer of the marine environment and you see species outside of what their normal range is, it's an ability to go into this website and you can download an app, take a photo, record the location of that species, and it's a way of us tracking the changes in the distribution of these species. So it's a good citizen science project for people to be involved in if they're interested. And finally, to finish off, what this long-term water temperature increase in the lobster fishery and the marine heatwave event has given us some experience. It's given us the researchers, the managers and the fishing industry an experience in dealing with these long-term trends and how do we all adapt to it, dealing with this extreme event. Now, I'm not saying the extreme event is a climate change event, but it is an extreme event, and the climate change, people tell us to get used to more extreme events in the future. Now, so this has given us an ability to deal with that. And what we've learned from it is that protection of the spawning stock is our key role. And to do that, early detection of the change of environment is important, and that's important to try and understand the cause of what's happening, and also to detect, hey, we need to monitor things closely. Monitoring the abundance of the stocks is quite useful, and if we can measure the abundance of the stock before they become legal size, like we do with a lot of our fisheries in terms of lobsters, pearl oysters, blue swimmer crabs in some areas, the scallops, we measure the abundance of those things before they become legal size, then that gives us an ability to be preemptive in our management measures. Oh, did I do that? It was the last slide anyway. So effectively, being responsive to these abundance changes is the key to my mind in terms of managing the climate change effect on fisheries. Okay.